Question number 2. Still linear expansivity, heat energy stuff. A brass rod is 2 meters long at a certain temperature. Full stop. The temperature is not mentioned. Let's see. Calculate the increase in length. We need to calculate the increase in length, okay? For a temperature change, for a temperature of 100 Kelvin. Yes. For a temperature change of 100 Kelvin, so to say, take the linear expansivity of brass as 1.8 times 10 raised to the power minus 5 per Kelvin. Options given are option A 0.3600 meters, option B 0.1800 meters, option C 0.03600 meters, and option D 0.0036 meters. Option E 0.0018 meters, and so on and so forth. Okay? So what do we do? Very simple. The same way we solved the first question is the same way we're going to solve this. So we write solution. Let's quickly outline our solution. Bring our data first. Okay? Our data. The brass rod is, that is initial length. Initial length. Alright, initial length L1 is equals to 2 meters dots. Alright, temperature change. There's a temperature change. For a temperature change of, that should be changed somewhere here. Temperature change of 100 Kelvin, right? Temperature change. Do we have another thing? Nothing. So we have temperature change should be theta 2 minus theta 1 is equals to 100 Kelvin. Or we can still write this in a very short form by writing just delta theta is equal to 100 Kelvin. Alright? That's it. That's the short form of temperature change. What next are we looking for? Okay? We need to identify this. The linear expansivity of brass is given as 1.8 times 10 raised to the power minus 5 per Kelvin. That's the linear expansivity of brass. Okay? We need to take this into consideration. We need to take this into consideration. Alright, so what next? We state the formula. Yes, the formula we are going to use is still linear expansivity is equal to change in length, alright, over original length and then temperature change, which is theta 2 minus theta 1. That is it. But we are asked to calculate the increase in length. The increase in length. Alright? So the increase in length should be L2 minus L1 is equal to what again? We take this alpha bracket, or rather L1 bracket, change in temperature, that is theta 2 minus theta 1, so to say. That is the bracket close. Increase in length should be, by the time we finish finding all these things, right? We now do simple subtraction to know what remains. So what has caused the increase in length? So under normal circumstance, we are looking for L2 minus what? L1 all equal to alpha L1 brackets. Or change in temperature, we can use delta theta at this point. So what we need to do is L2 minus L1 is equal to, watch out, is equal to what? Linear expansivity is 1.8 times 10 raised to the power minus 5. Okay? That is it. We are now substituting, right? For this linear expansivity, we have this. For length 1, we have 2 meters. Okay? Times 2, right? For change in temperature, change in temperature is 100 Kelvin. 100 Kelvin. So we may not have much problem there. 100 Kelvin bracket close. All that. Yes. That's what it should be. That is what it should be. And then by the time we are done, calculate this. whatever we have, alright? Because we're looking for L2. Change, okay? They say, calculate the increase in length, L2. Increase in length. So whatever we have here, minus L1, all about this. Okay, like this times this is 200. So we have 1.8. 1.8. Let's just go 1.8 here times 10 raised to the power minus 5 times 200. 2 times 100 is 200, okay? 200, bracket close. So what you're going to do is very simple. At this point, use a calculator, press 1.8. Let me write this well. This is 1.8. This is 1.8. Where's my chalk, okay? 1.8. Okay? Press all this and then do what you're supposed to do here. Convince yourself that your answer corresponds to one of these options. Convince yourself. You need to do that. I have outlined the data. I have stated the formula. I have also substituted where necessary. Then you're going to do this. Press a calculator, simplify further, find the increase in length, and then put it here in the comment section. And I want to read your comments, yes. I want to see those comments. Subscribe, give me some thumbs up, all right? And share with your fellow students, or share with your students, so to say. My next class is coming soon.